So let's go ahead and take a look at Canvas real quick, and then we will get going. So something I always point out, although you probably read this by now, is in Canvas for any of your classes, you can change this part right here. You can go up here, hit the little dots, and then change it to say whatever you want, whatever color you want. So I usually like to write in like the time and place of the class. So I have Monday, Wednesday, Friday, 12 to 1 on there just because I find that helpful. So I remember when and where things are. Ooh, okay, so the home page currently is the syllabus. That's going to change probably by the end of the week to just be the modules because that's where anything useful actually is. But we should go over the syllabus real quick because I'm supposed to. So let's take a look at the syllabus. Co-17C again, you're here now. Everyone, I'm very happy to see so many of you here in person. I hope it continues. I think it's a better class dynamic when there are more people here. I think it helps me do a better job. Also, I think you get more out of being in person. That said, if you need to come, well, we'll talk about attendance in a minute, but you're always welcome to come via Zoom like someone is right now, or watch videos later with some caveats. So let's go ahead and, yeah, you're all here, Zoom, cool. Also, you should ask questions if you have them. I'm just kind of mentally in my head be like, yeah, we're fine. So how can you get a hold of me? You can email me is usually the easiest way. You could try calling me, but it's unlikely that you will, because now like our phones are through Zoom, so I have to have Zoom open on my computer and I kind of forget to do that. So don't call, email me if you want to get a hold of me. You can also come by my office if I'm there, or most likely you find me in office hours, which we'll look in the modules a little later on to see when and where they are, but you can find them there as well. As far as the grading, so just to make sure everyone's on the same page about how the class works. Some of you are enrolled, registered for the class, meaning you signed up with the CRN via Schedule Builder, and some of you are not, which is totally fine. I don't care how you're in this class, except that for those of you that are actually registered, meaning you signed up with the CRN, you have a workload unit in your Oasis, I don't know whatever system we're using, you are required to attend in person. So that's it. Really, so for those of you that are just in Canvas and not actually registered for unit, you can come however you please. However, I would really like it if you came in person as well. So all of you should come in person, but if you're trying to get a unit for this class, the attendance in person is really the way I do it. So, and that said, speaking of attendance, I should pass around the sign-in sheet. So please, your name, if you were either in Canvas or, well, if you're in Canvas, you should be on this. If you're not, just write your name at the bottom, but I think most of you are in. You don't have to be in the Canvas to be here. I think you're missing out if you're not. So if any of you aren't in Canvas and want to be, let me know and I will add you to Canvas. It's pretty easy to do. That's where I post all the things. Getting darker outside. All right, so again, as far as grading, for those of you that are registered for a unit, pass no pass class, a passing grade is 70%. Attendance, meaning you came 70% of the time, which for this class means 70% of 28, which I think works out to be 20 class sessions. So you got to come to 20 of them. You should come to all of them, but I understand sometimes life happens. You got other things going on. You don't have to come to all of them. That's it. Let's see, what else is there right here? So yeah, if you're enrolled, you use the CRN to sign up. You're required to attend in person. If you're not enrolled, meaning you either got added by me or you filled out the form, the Google form on the AATC website to get added, you're not required to really do anything. You're great. So for those of you that are not enrolled, like that you just signed up via Google, totally fine. Your grading Canvas, which you will see, doesn't matter at all. So don't worry about your grading Canvas. If you are enrolled, your grade definitely does matter if you want to pass this. Also, not passing this class is not that big a deal, but also, right, if it were me, I would want to pass the class, right? Yeah, I'm going to pass, but not passing, not a big deal. Let's see here. You all should read this at some point if you want to. If you do not attend in person, totally fine. As far as those of you, as long as you're not worried about like passing the class. But if you attend virtually like someone is right now, and I sent them the form to fill out, or if you watch the video later, I would really, really, really appreciate it so much if you would fill out this form here, which I need to update, I think, probably. Let's take a look. We'll find out. No, I need to update it. So it doesn't say the right classes currently. So I will sorry. So for you online, I will update this form and fill it out later. But basically, you're just going to go ahead and put in your email, your UC Davis student ID number, your first name, last name, and then the class you're taking, and then how you attended, and then, oh, this is like a really old one. I will go fix this. Live in person shouldn't be an option anymore. And then very importantly, the date, please get the year right. I have to go through this data and look at it later, and it really helps me if you actually enter the date correctly. This is only if you're not in class in person. So for those of you in person right now, you never have to do this if you always come in person. But if you do come virtually or you watch a video for a missed class later, it would really help me if you did this, because I'm supposed to track the attendance data for all the students I see during the quarter or who watch my videos during the quarter. So doing that helps me correctly fill out some forms, and also helps us justify getting funding from a certain part of campus. So please do it, because we need all the funding we can get. All right. That said, we can be done with that. About this class, if something's impacting your success in math, please don't hesitate to talk with me about it. I am a resource for you. Something is said in class by anyone, including me, that makes you uncomfortable, please talk with me about it, or someone else if it's me, I make you uncomfortable. I've never had a problem. I don't intend to make anyone uncomfortable, but you never know. It could happen. So if there's an issue, let someone know. We'll handle it. You know where the class is. As far as how class works, usually it's me showing you examples, and we'll try my best to incorporate opportunities for you to try stuff before I just go on through and be like, this is how you do it, because I think you would learn better by trying to do the things before I'm just like, well, here's how you do it. So that's on me as much as it's on you. But that said, please come prepared to write stuff down and to think about math, because that's what we're here for. What else? Yeah, like I said right there. Accommodations. If you have accommodations, send me the email. Although most of the accommodations for this class are kind of not particularly meaningful, because there are no exams, there's no homework. I'm recording it already, but if you need to do any of the things you need to do, if you have an accommodation, you are welcome to do it. But as far as the actual like testing accommodations for extra time, that's not really an issue in this class because there's no exams. That said, if there is something, I will look at it. I've seen a couple of accommodations, I think, for this class, or maybe I actually don't know which class I didn't look, but I was like, yeah, sure, I'll do the thing because the thing is already being done. What else? Zoom instructions. Nobody needs to read that. Notes about Math 17C in the class. It's a one workload unit, meaning it counts towards doesn't count towards graduation, but does count towards being a full-time student, meeting minimum progress requirements and financial aid requirements. Yeah, there's stuff there that's not that important. I've tried to get students to use the discussion tab. It's never happened. So we'll just go right there. You're going to be spending some time on math. Successful students usually spend 10 to 20 hours per week outside of class doing homework, etc., practice problems. So plan on dedicating time to this class. I think you all probably know this already because you've been through the first 2 quarters of calculus, so you recognize that, yes, it takes some time. Where can you get more math help? You can get tutoring help from the AATC. Let's click on this link here just to see where it sends us. Sure. I think somewhere here you can sign up for an individual tutor. Like here, I think whenever I click here, it takes me nowhere because I'm not a student. You have to log in as a student. But if you go back to our main AATC webpage for math, and then click on the OASIS scheduler, you can have a one-on-one drop-in tutoring appointment. You can also just go to drop-in. That's where you'll find a lot of help. Yeah, and then of course, there's always each other. You guys should get to know each other. Some of you probably already have. Working with your classmates is probably the best way to continue having success in your classes. All right, so that's all the syllabus stuff for the most part. You can look at it at your leisure if you want. I will change the homepage to be the modules probably by the end of the week. This is my view. So you'll see some stuff here that you won't see right now because like anything that doesn't have a little green check mark next to it, you won't actually see as a student until I publish it. But as far as things you can see currently, useful links, the links to the attendance form, my office hours, which are kind of weird. I guess I don't know, weird. They're just in different places. Like usually when I have office hours at a certain time, like a Monday, Wednesday, Friday, or Tuesday, Thursday, they're usually in the same place. That's not true this quarter. So Monday, Wednesday, Friday, I have office hours from 1 to 4, but they're in a different place each day. So on Monday, they're in drop-in. On Wednesday, they're in C class. And on Friday, they're in CADS. I also have office hours Monday and Wednesday, 10 to 11. also in different places on Monday in CADS, on Wednesday in drop-in. And finally, Tuesday, Thursday, I have, right, exactly. So if you want to find me, you should go look here. So you'd be like, where the hell is James today? Oh, this is where it is. Okay. Because I'll probably be looking there too. Because yeah. Also office hours, not today, not Tuesday, starting Wednesday in the student centers. So like in CADS and C class, starting next Monday, well, Sunday actually, for drop-in. So drop-in in the library doesn't start until Sunday from, I think, 3 to 7 p.m. on Sundays. And then the following Monday is when I'll start being in drop-in when it's there. C class is the Center for Chicanx Latinx Academic Student Success. It's the place for up above the coffee house. So if you know where like the flag is on the north side of the quad, there's those stairs there. You go up those outside stairs and just veer to the left. It's right there. Yeah, I'll be in C class on Wednesdays from 1 to 4. I'll be in CAD, which is the Center for African Diaspora Student Success, on Fridays from 1 to 4. And then on Mondays from 1 to 4, I'll be in drop-in. Very straightforward. But I mean, really, if you're not sure where I am, you can look here and it'll be easy to figure out. Or I think you can maybe look on my website. Let's see, did I update my website? Good question. Which should be, we should do it from here because it should be linked in here somewhere. Office hours, Grant's website, we'll talk about it in a second. My website, yes. Cool. Yep, there's me. But I have not updated. So I need to update my website. So I'll do that today. Yeah, good job, James. All right. Cool. Later. So that'll be there, but it's really not particularly useful because anything you find on here, you can also find in our Canvas. So I wouldn't go to my website unless you forgot you were locked out of Canvas and you needed to find out what office hours were. Back to the modules. Let's see what else is on there. And then we'll do a little bit of math. The syllabus from the math department, you might care to look at it just to see what's coming up next. It just kind of lays out the sections we're going to go through and how much time your instructor should be spending on those. Not that anyone is required to do anything really, but this is what your instructor should be doing approximately. Usually there's some variety because people work at different paces. Back to the modules. And then let's see what else we have here. So I will post the class videos on YouTube. We are recording. Okay, good. You can find them there. I'll also post them in Canvas, which I really should stop doing. It just makes me go to YouTube, but whatever. Maybe next year. Did you have a question? No, oh, sorry. I see like a half fan. Like, yeah. And then there's Grant's website, which to be perfectly honest is where I get most of my source material from because Grant is my coworker. He's teaching the other co-class for 17C this quarter. So he's also a wonderful resource in general. But a lot of these handouts or notes he posts are what I usually kind of take inspiration from or just blatantly copy. The math is changing. I do try to change them slightly so that you can have like a different example if you go look at his examples so that at least the numbers are a little bit different. Let's see what else here. And then there's some links for graphing utilities, which we'll get to when we need to. And then there's a whole bunch of exam prep material that you can't see yet because we're not taking exams yet. Then there's some handouts, which we'll talk about in a second. And then there's the recordings from last year or last quarter, I should say, for Lee's class specifically. So if you want to watch more of me talking, you can. It's not particularly exciting because it's me talking. I don't know, watching recording to me just feels it's not how I prefer to ingest content. So I would rather read the class notes. So if I was looking for something, in fact, if you do care to watch the videos later, I would encourage you to also be looking at the notes that accompany them. So I will also, whatever notes I write here, which you can't see right now, but whatever notes I write over here, I will also scan and post those. And then you can usually find them right below the video recording that they go with. So right, you can see recording notes, et cetera, et cetera, et cetera. And then anything else to say here? And then I'm curious, it's okay if the answer is no. Actually, raise your hand. Raise your hand if you looked at the spring break prep work I posted. All right, it's pretty good. It's more than I expected. Cool. So I would say that this is worthwhile. I might have enough physical copies for everybody. If you already have worked on it, probably don't take one, but I would encourage all of you to, when you have a chance, not right now, to look at this material. It's pretty it's meant to be fairly straightforward graphing things because we start off right away talking about graphing in 2 dimensions because that applies to how we're graphing in 3 dimensions. We're talking about 3 dimensions. And really, there's a number of reasons why we want to talk about it. But I would say, I think if all of you, I think all of you should try to do this handout before next class, before Wednesday. It's not that long. There are solutions posted on Canvas already, which I hesitate to tell you because really you should work on it before you look at the solutions. Yeah. I think that's all I have to say as far as class logistics. Questions or comments? I have any questions or comments? If you come in late, totally fine. I'm trying to be on time, whatever. But if you somehow miss the sign-in sheet because you come in late, just come and fill it out then in class or whatever. Don't worry about like, I can do it right now. Also, if we're like mid-class and I've forgotten to send this thing around, please let me know. I usually am pretty good about remembering it, but occasionally once or twice I've forgotten. And then students have been like, James, where's the thing? I'm like, oh yeah. Yeah, I think that's about it. There's some other stuff here, which we'll get to later. All right. When does Lee's class meet? 10 to 11? And how about Varn? 34. Okay, cool. So Lee's already met. Varn has yet to meet. Cool. All right. I would say also just very broadly, a few things about me writing, which you may or may not know. My writing is mediocre at best. If something's unclear, please ask for clarification. I'm happy to clarify. I'm not offended. I know what my writing looks like. I've been doing it for a number of years. So yes, I know this is not beautiful, but it's usually legible. If I get off, also sometimes I might be writing down here, just say, hey, James, we can't see the paper. You don't have to like wait for me to like call on you, just be like, hey, James, we can't see him. Oh yeah, thanks. What else? You can call me James, but if you're uncomfortable calling me James, that's totally fine. You can also call me Mr. Parmenter, but it's a lot more to say. James is so much easier. So I like the name James a lot. So you should call me James, but I get it if you can't. Just trying to make sure I've said all the things before we start talking about the math. No, I think we're good. Okay. That said, you're always welcome to ask questions. And you're encouraged to ask questions. So if something feels like you could use more clarity, please don't hesitate. Also, if I don't see you because I'm down here, you can say my name to get my attention. All right, let's spend the last 28 minutes here talking about some functions of multiple variables. This is not the primitive grab. Specifically, functions of two variables. The functions of several, oh my gosh, several, usually two though, variables. So some examples. The volume of a cylinder is a function of its height and radius. So if we draw a little picture here. Problem with having a week off is you forget how to write things around. I feel like I'm like, have I not practiced writing things in a week? Yes, I have. It feels unnatural here. So this cylinder with a height of h and a radius of r, we can say that the volume as a function of those two variables is pi times r squared times h. There's two unique inputs that are going to give us one unique output. To carry this example a little further, if the radius is 10 inches and the height is 8 inches, what's the volume going to be? Well, we're just going to sub those values into the function. So V of 10 comma 8 is going to equal pi times 10 squared times 8. I'm not writing in the units. We could. I find it a little bit cluttered, to be honest. We're going to write the units at the end. So also for future classes, you might find not, I mean, I know we're kind of full, but you might find sitting over there is not the most ideal seats because I feel like I'm kind of in the way here. So yeah, I wish this was not there, but I don't have a choice. So I would choose your seat accordingly next class because you might be able to see better if you sat back there, for example. That said, I also try to sail the things I'm writing most of the time. Here we're going to get 100 times 8, which is 800, so 800 pi. And here's how I would figure out the units. Are we talking about a length, an area, or a volume? A volume, so it should be some dimension cubed. My units were in inches, so it should be inches cubed. Or we could say it's inches times inches times inches. Oh yeah, that's inches cubed. But the units should make sense based on whether you have a length, an area, or a volume, or some other thing that's none of those, right? There's like miles per hour or feet per second or. An interesting question here is, what's the domain of this function of two variables? Well, there's two ways to answer this. And it actually kind of matters which way we're thinking about this. If you look at this function here, pi r squared h, there's none of the usual domain problems. There's no division by 0. There's no even roots like square roots or fourth roots, and there's no logarithms. So you might, I would say incorrectly, say that the domain is all possible values for r and all possible real numbers for h, positive, negative, etc. But then if we look at the actual thing we're doing here, some of those don't really make sense. It wouldn't make sense to have a radius that was negative. It wouldn't even make sense to have a radius that was 0. So really, our domain here should be all possible combinations of radius values and height values where both are positive. Now, that's not the same as saying all positive numbers, because it's not just one input we're talking about. We're talking about two inputs. So here's what our domain looks like. It looks like some part of the XY plane or the two-dimensional plane. I'm going to say it's the H, well, that's the RH plane. So usually when you're drawing this, whatever is your first input gets the x-axis, and whatever is your second input gets the y-axis, just like we usually write xy as x comma y. So I'm thinking of this as my r-axis, this is my h-axis, and the domain is everything where r and h are both positive. So if I'm drawing it, it looks like everything in quadrant 1, exclusive of the axes. So actually, I've kind of drawn this badly. I apologize. Usually, if you're excluding a line, you would draw it dashed. But I drew them in, so we'll live. We'll do it better next time. The way you'd write the domain is that the domain is equal to the set containing all ordered pairs r comma h, such that, so the vertical line tells us, r is greater than 0 and h is greater than 0. I don't think it's particularly useful to do this because it's not really telling me anything I didn't already know. I think graphing it is the most useful thing about the domain here, is seeing what part of the XY coordinate plane or the two-dimensional coordinate plane we get. But this is the correct way to write a domain for a function of two variables. It's all the coordinate pairs satisfying whatever conditions make sense or whatever conditions are required. But you would never say it's all real numbers, because all real numbers means you're only talking about one of the inputs, not both of the inputs. Let me give you another example. So just as a real quick example, let's say our function was f of x comma y equal to x cubed times y squared, without any context. All right, we're just saying here's a function of two variables. Has no meaning that we know about. Here, we don't need to think about any context or about things needing to be positive because they are representing a length. We can just get anything. So here, our domain would be, again, it's not going to be all real numbers because we're not talking about numbers, we're talking about pairs of numbers. So the domain is going to be the set containing all coordinate pairs x comma y, such that both x is real and y is real. Or x is any real number and y is any real number. Positive, negative, rational, irrational, zero, etc., etc. And drawing this almost looks silly because we're just going to draw a coordinate plane and then essentially shade it all in. So our domain here is everything. Another way we could write this, if we wanted to use less words, would be the entire coordinate plane is the domain. One more example in a similar way. Well, that's not true. There's never just one more. Let's look at the next example. I always say one more and then one more after that, and then one more after that. Let's talk about BMI, body mass index. For those of you who are unfamiliar with the acronym, body mass index is a poor measure of obesity or I don't know what the other word. Like there's like you can be obese or like really obese. Like what are the I don't know what the regular words are. I just always think about the obese part of it because that's the part that we all look at for some reason. But BMI is measured as your mass in kilograms divided by your height squared in meters. And I think if it's like between 20 and 25, you're like it's a regular BMI, and over 25 is obese, and under 20 is whatever the word is, emaciate, I don't know, doesn't matter. The point is, I want to talk about, well, actually, first of all, let's calculate. So what we're really saying here is the BMI, I wanted to write this as a function of two variables. It's B of M comma H. So for example, if our mass was 70 kilograms and our height was 2 meters, it's a little taller than 6 feet tall, our BMI would equal 70 divided by 2 squared, which is 70 divided by 4, which is 35 divided by 2, which is 17.5. A fairly low number, I think. Again, not a great measure of what they're trying to measure, but somebody came up with it and people still use it. How about the domain here? And again, this is one of those questions where we have to think critically about the domain, right? You could, if you were just looking at this as a function of two variables and not thinking about the context, you could say, well, the mass could be any real number, positive or negative. The height could be any real number except for 0. But that doesn't really make sense, right? We shouldn't be getting negative. Oftentimes, when we're measuring things, we are excluding negative numbers because those don't make sense. Here, I might also exclude some heights that or masses that don't seem reasonable. Like, I mean, even for an infant, right? They're still going to have usually some non-zero mass. So I might say a reasonable domain would be that the mass should be bigger than or equal to 1 kilogram. And the height bigger than or equal to, let's see, a meter is like 3 feet. A tenth of a meter seems like a pretty low bar for the height of an individual. So we'd say 0.1 meters. And then our domain, if we graph it, is going to look kind of funky. I wrote mass first, so mass should be on my horizontal axis, height on my vertical axis. And I would just label it so it works for me. So we're going to put a 1 there. We're going to put a 0.1 there. And then everything bigger than 1 for mass, bigger than 0.1 for height. And then everything that's over. There's my domain there. And I've written these as solid lines to make sure that those values are included. If I did not want to include them, I'd write them as dashed lines or dashed curves or whatever kind of thing it was. There's something else. Oh yeah, I'll point out here, I didn't, so I guess technically, see, I think this is good enough. There's your domain. We've explained it. We've written it down. But if you want to be like precise about it, we should write it using the set notation. The domain is the set containing the ordered pairs m comma h such that the mass is bigger than or equal to 1, and the height is bigger than or equal to 0.1. So I'll say it again. If a problem has context, if it's measuring something in the real world, you should think about what it's measuring to inform you as to how the domain should work. But then we're going to have things that don't measure anything at all, really. For example, how much time? This clock is going to kill me. I'm sorry, let me move this. This clock is like 15 minutes too slow, which is distracting. So let me cover it up there. Cool. So we still have like 60 minutes. Talk more about domain. So let's look at this example and I'll start numbering things. So we have the function without any context. F of xy is equal to the fourth root of x minus y squared plus 1. And I would like to find the domain of this function. So we're going to say, well, we know how roots work. Just like in 17a, we found the domain of something, we set the inside of a square root or a fourth root or a sixth root to be bigger than or equal to 0. That's what we're going to do here. So our domain is going to be, well, we have to solve the inequality x minus y squared plus 1 is bigger than or equal to 0. Most of the time, I would say we should solve for y. We should isolate y. This is one of those times where I don't think that's the case. Since I don't really want to have to introduce the square root if I don't have to. I would much rather isolate x here and say, okay, x is going to be bigger than or equal to y squared minus 1. Adding y squared to both sides, subtracting 1 from both sides. Because I can draw that. On the other hand, if I did y, I don't really want to deal with x plus 1 bigger than or equal to y squared and then square rooting both sides. Because if you're introducing a plus or minus, that becomes problematic with an inequality. So don't do this. If you've got either x by itself or y by itself, solving for that's fine. If you've got x squared and y squared, we'll talk about it. So this is our inequality. Great. Let's graph it. So we're going to graph it is by just graphing the equality. So we're going to graph the equation x equal to y squared minus 1. And we're going to look ahead, meaning, here's what I mean really. If you're doing an inequality that's a greater than or equal to, you want to include the boundary, so we're going to draw it solid. If this was a strictly greater than, when I graphed this, I would graph it as a dashed curve, which we'll see in the next example. But since I know I'm going to want to include this, I'm just going to draw it normally, regularly. So let's see. I'm graphing x equal to y squared minus 1. That's a parabola. Opening which way? Left or right? To the right. To the right, right? Right? So if it was y equals x squared, it'd be opening up in the positive y direction. But since x equals y squared, it's opening right in the positive x direction. Think about it this way. If y is like 5, x is going to be 25 minus 4. Oh, yeah, we're going to go way to the right. Right? You can also plot points, right? If you're not sure which way the parabola goes, plot a few points. If y is 0, x is going to be negative 1. If y is 1, x is going to be 0. If y is negative 1, x is also going to be 0. If y is 2, 4 minus 1 is 3. Sorry. Yeah, so this is right. I was almost going to do it wrong. Right? I was about to graph x equal to 2. If y is 2, x is going to be 4 minus 1, which is 3. So x is 3, y is 2. Or if y is negative 2, x is also going to be 3. So yeah, we can see it's a rightward opening parabola. And usually what happens is you get all of the points on one side of the curve. So it's either everything over here or everything over here. And the way you can figure out which side it is by testing any point. Let me rephrase that. We're testing any point that's not already on the curve. So usually if the origin isn't on the curve, I'm going to try the origin. So here's the origin over here. And the question is, does x equal to 0 and y equal to 0 satisfy the inequality? We'll plug in the points and see. Is 0 bigger than or equal to 0 squared minus 1? It sure is. 0 is bigger than or equal to -1. So that means the point 0, 0, and all of the points on this side of the curve are in the domain, including the points on the parabola. If we wanted to write the domain, we would say, yes, it's this. The writing the domain part's like the boringest part. It's also the easiest part usually. If you know what the domain is, you're just saying, cool, it's all the points that do the thing that I already said they had to do. In this case, all the points where x is bigger than or equal to y squared minus 1. I will point out as well, if we had picked a different point, let's say we picked the point 0, 2, which we already know isn't going to work out, but let's check it anyway. So does 0, 2 satisfy? Satisfy. Well, here's 0, 2 right here. We're thinking it's not going to work, but let's check. So if x is 0, it is important to make sure you get the right value for the right variable. It's easy to mess them up if you're not paying super attention. So if x is 0 and y is 2, is 0 bigger than or equal to 2 squared minus 1? Obviously not. No. So that means that point and all the other points on this side are not the domain. We want the other side of the boundary. So usually the boundary separates the domain from the not domain. You have to figure out which side of it you want. All right, let's look at a couple more examples and then we'll call it a day. All right, let's look at this. Yeah, I'm gonna change that up. Yeah. Let's say our new function is g of x comma y equal to, sure, 6x plus 1 over, yeah, I like that, the square root of x squared plus y squared minus 16. So still a root. And normally, we start off by saying, well, okay, everything in this square root, x squared plus y squared minus 16, has to be bigger than or equal to 0. But we know something else here. We know it's in the denominator. So we know that setting it equal to 0 isn't really going to work for us, right? We don't want to divide by 0. So we're going to skip the step of writing bigger than or equal to 0 and say, hey, we know it needs to be strictly greater than 0. And this is a case where we have an x squared and a y squared. And usually what that means for us, not always, but often, it means we're going to have some sort of circle. Not always, and we'll see later, there's some other weird stuff we have to deal with. But for now, it usually is going to be like, oh yeah, we're going to get a circle. So we're going to isolate the x squared plus y squared. And that's our domain. X squared plus y squared is strictly greater than 16. Okay, so again, just like last time, I'm not going to try and figure this out until I graph it. Really, I would say the graphing of these things is kind of, at least in my opinion, the important part. So we're going to graph not the inequality, but the equality. So we're going to graph x squared plus y squared equal to 16. But we know when we graph it, since we don't want to include the boundary, I don't actually want x squared plus y squared to equal 16. I want it to be bigger than 16. So I don't want to include the boundary. So when we graph it, we're going to graph it as a dashed curve. Kind of like how you graph a horizontal or vertical asymptote, right? How you do it like a dashed line. It's a curve, right? It's not a line. Okay, x squared plus y squared plus 16. It is a circle. What's the radius? Show me on your fingers. Great. And the center is the origin. So graphing this, 2, 3, 4. Doesn't have to be perfect. It'll look decent. I'm telling more myself than you all. So we're graphing this as a dashed circle. Pretty circular. And then we're going to test a point on either side. Just don't test a point on the curve. So you wouldn't want to test the point 4, 0. because we know we don't want it. I'm going to test the origin. Usually the origin is a good choice. So is 0, 0 in the domain? You obviously do not need to write this question down for your own self in general. I'm writing it down because I'm writing down how I'm thinking about finding out what the domain is. Well, let's check it. Does 0, 0 satisfy this inequality? Is 0 squared plus 0 squared bigger than 16? No, it's not. So 0, 0 is not in the domain, meaning every point inside the circle is not in the domain, meaning all the points outside of the circle are in the domain. You can test one if you wanted to, but you don't really need to. Once you figured out that one side isn't the domain, the other side of the boundary is the domain. But if you want to check, you can check a point like 5, 0 and see that, oh yeah, if you plug in 5 for x and 0 for y, 5 squared plus 0 squared is certainly bigger than 16. It's 25. So all the points outside of this dashed circle, there's your domain. And then we could write it. So our domain here is the whole set of points x comma y such that x squared plus y squared is bigger than 16. Hopefully you can understand why I feel like it's kind of silly to have to do this. We already really did it. We already knew what the domain was and we graphed it. Writing this to me feels extra, but sometimes that's what people want you to do. Same time. Or let's do one more. Oh, yeah. Okay. So looking at one more example, just to throw a logarithm in there as well. What if I wanted to find the domain for the function f of xy equal to log base 3 of 9 minus x squared minus y squared? Find the domain. The sun going away and coming back is really throwing me off here. Let's see, I feel like there was something else I wanted to say. So I want you to set up the inequality that you should set up to try and start finding the domain. I'll give you 30 seconds. And you can try to start solving it if you've set it up. That should be the inequality we're starting with. 9 minus x squared minus y squared, or more generally, anything we're taking a logarithm of should be positive. I see an x squared and a y squared, so I'm going to try and isolate those together. You could leave them on the left. I would rather add them to the right. So you could say it's 9 bigger than x squared plus y squared. Or if you prefer, you could do it the more complicated way. Say it's negative x squared minus y squared is bigger than negative 9, and then multiply both sides by negative 1. And get x squared plus y squared is less than positive 9. Same thing, right? I would rather do this, but if you do want to do this way, it doesn't matter. All right, again, we're graphing a circle. We're going to graph x squared plus y squared equal to 9. We're going to graph it dashed because we don't want to include the line, the curve. Circle of radius 3, send it at the origin. Dash looks like this. Kind of like that. And then once again, do we want the insides or the outsides? Or the left side or the right side? Or what the stuff separated by the boundary? Which side of it do we want? Let's test the origin. That's usually my go-to if it's not on the boundary. And yeah, it works. 0 squared plus 0 squared is less than 9. It sure is. So here we want the insides, not the outsides. all the stuff inside, but not on the circle. So here I would write the domain as the set of all coordinate pairs, x comma y, such that x squared plus y squared is less than 9. What about the range? So the range is actually more similar to how you're used to thinking of it, as that it is just an interval. It's just some set of output values which don't have like two coordinates. So the range here, and I know we're almost out of time, the range, you're asking how big and how small can the function get? Well, logarithms, fortunately, are increasing functions, right? If you think about how a logarithm looks, I know it might have been a while since someone showed you this, but if you look at your right hand, kind of got a logarithm right there and e to the x right there. Your hands are probably much better for this than mine. But if you have a logarithm right there, oh yeah, it's increasing the whole time, which means it's getting bigger. So the way you, if you increase the input, what's the biggest the input could be here? I disagree. If I'm thinking of the input as what's inside the logarithm, how big can this ever get? 9. If you write it in a more suggestive way, write it as 9 minus x squared plus y squared, you're like, oh, this is always bigger than or equal to 0. So 9 minus that is always going to be less than or equal to 9. So 9 minus x squared plus y squared is always less than or equal to 9. But it does go as negative as, oh, but it can't be super negative because it has to be bigger than 0. And then if we take the log of everything, the log base 3 of 0, which I know is undefined. Don't kill me for that one. The log base 3 of that. And the log base 3 of 9. Well, log base 3 of 9 is 2. And log base 3 of 0 is not the best thing I've ever written in my life. What I should really say is we're approaching 0 from the right. And we know that the logarithm, as you approach 0 from the right, goes down, 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 down to negative infinity. What we're really saying here is our range is that our function gets as negative as we want it to and can be as big as 2. I know I kind of threw that in there at the end. We can talk more about that on Wednesday. But that's our range, negative infinity to 2. All right. Nice meeting you all. I really, really, really encourage you all to do that handout. It's not that much work. I think it'll set you up for understanding this domain and range stuff just a little bit better. And I look forward to seeing you on Wednesday. And if you didn't get to sign the sign-in sheet, please make sure you do so before you leave.